Okay, so welcome back. And now we're going to do an example of using the formulas to find the vertex and the y-intercept for a quadratic function, and then sketch the graph using also something called symmetry. Okay, so in this case here, what is our A, B, and C? So A equals 2, B equals, now in this case here, remember, the general formula is ax squared plus bx plus c. So again, so b is going to be negative 8, and then c is positive 6. Okay, so now, to find the x-coordinate of the y-intercept, we just use our formula, negative b over 2a. Negative b divided by 2a. Now, negative b is the negative, so negative of negative 8 over 2 times a, which is 2, which gives us 8 over 4, which gives us 2. And then all we have to do to find the y variable is just do f of 2, right? And so that gives us 2 times 2 squared minus 8 times 2 plus 6, which gives us what? Which is going to give us 8 minus 16 plus 6, which gives us what? This is going to give us a negative 2. Okay? And so we found that the vertex is going to be 2 comma negative 2. Okay. Now, what about the y-intercept? Well, that's easy because all we have to do is plug x0 in for x, right? So when x equals 0, y equals what? 6. So our y-intercept is 0 comma 6. Or 6. Okay, now at this point we can graph our equation. We've got the vertex, we've got the y-intercept, but we're going to need another point to graph. We need at least 3 points. Sometimes it's good to have more. Okay, so one of the things we could look at is the x-intercepts. Okay, but we can also use symmetry to find a third point. For example, we know that the vertex is on the line that basically cuts the graph in half, right? So if we graph our graph again, let me set this up better. So we know there's a line of symmetry that goes right to the vertex, right? The vertex is the bottom point, right? So this is at 2, negative 2, right? So that's what we found. And we know that the y-intercept goes through 0 comma 6. Okay? And we know that this graph opens upward, right? Because A is positive. But we can find a third point to graph, right? So we've got the this point and this point, let's say. Okay? Well, we could find the third point by using the fact that we've got this line of symmetry and we've got 0 comma 6. So 0 comma point is how many units from the line of symmetry? It's 2 points. Well, that would mean that the next point that this that this graph goes through would be on the mirror image of that. So it would be the point that's reflected across this line of symmetry. So since this is 2 units from the line of symmetry, then the other one would also be 2 units from the line of symmetry on the other side. So that would mean that the other point that this would also go through would be what? 4, 6. So if we go to 4, 6, right? So it would be right about there. And so we could sketch the graph through that point, okay? So we could use symmetry to do it. We could also find the X-intercepts, right? We could find where along the x-axis that the parabola intersects. Now, if it does. Now, again, not all parabolas have X-intercepts, but if they do, we could plot those as well. And so in this case here, the X-intercepts are at 1, 0 and 3, 0. Okay, because this is from the other example that I did. Okay, so let's do another example where we can use the X-intercepts. Okay, and again, how do we find the X-intercepts? We could use all the other things that we've talked about in our toolbox: factoring, the quadratic formula. Those are all things that we can use to find the zeros of a quadratic equation. See you next time.